We had 2 projectile motion questions for homework last night on page 109. I definitely want to go over question number 2 because we had that challenge there. We had that challenge at the end of question number 2 to see what's the maximum height of the ball. I'm curious if anybody got that, but I don't necessarily expect you to have gotten that. Do we need to go over number 1 as well, or are we good with number 1? Anybody for number 1?
Yeah.
Both of them? Okay. Yeah, okay, let's do both of them. Number 1 says a ball thrown horizontally at 10 meters per second travels for 3 seconds before it strikes the ground. So it's thrown off of the edge of a building. It's thrown off of something up high, right? Okay. Maybe it's just a really, really tall person that throws it. Okay, that takes the ball 3 seconds to land. But in the end, it doesn't really matter what it is. It falls a certain distance like this. The velocity of that ball is 10 meters per second as it's released, and it travels for a total time of 3.0 seconds. We want to find this distance, and we want to find this distance, the horizontal displacement and the vertical displacement. So what do? Do we have a funny angle here, guys? No, we don't. So that's good news. We don't have to go off to the side and get rid of that funny angle. First thing we'll do, therefore, is go directly to my x and y components. My x component is always described by which equation? Which equation do I have to write down for this? Go ahead. Good. V is equal to delta D over delta T. You need to write that down every single time. On your unit test next Thursday, you'll get at least 1 projectile motion question, maybe 2. On your final exam, I already told you this, question number 1, written response question number 1, is a projectile motion question. On all of those questions, you need to start off this way. X is V equals D over T. And Y, well, it's acceleration, right? It's a group B problem. Which equation am I going to start off with there? We're not 100% sure which one that we should use for the Y component like we are for X, but we're like 99.9% sure. Okay, this one almost always works. Which one is it, Mackenzie? Good. D is equal to VIT plus 1/2 A T squared. And then, hey, the strategy then is pretty loose, right? We just plug in numbers and find what we find. Hopefully we get something that we're looking for pretty quick. If we don't, it's okay. We get something, then that's going to help us to get what we're looking for. All right, do we know what the x component of the velocity is? Do we know what the x component of the velocity is here? Sabina? Good, 10 meters per second. Do we know what the horizontal displacement is there? Go ahead. No, we don't. So let's just leave that as a blank there. Do we know what the time is? Yeah. Look at that. Most problems that we get, we don't have the time given to us, right? We're usually solving for time. But this time we actually have it, which allows me right away to find the horizontal displacement. 3 times 10 is going to be 30.0 meters. First part of the question, A, done. Didn't even need to do the y component for A. If it was just question A and no question B involved, I'd be done. I wouldn't even have to bother with the y. But, alas, they do ask me question B, so I got to do the y component. Do I know what the vertical displacement is there? Tyson, do I know what the vertical displacement is? No, I don't. That's what I'm trying to find, isn't it? Do I know what the initial velocity is for the y component? No. No, is that right? Yeah, I do know it. It's 0. If it's thrown horizontally, okay, initially it's not traveling up or down. Now, 1/10 of a second after it's released, it is traveling up or down, probably down. Well, it would be down. But as it's released, it isn't traveling vertically if it's thrown horizontally. So we're going to say 0 times time is 0 plus 1/2 of negative 9.81. That's the y acceleration times the time of 3.0 squared. 3 squared is 9. 9 times, I don't know, what is it? Let's just cheat and look at the answer here. 44 meters. Works actually to be negative 44, doesn't it? Katie, I just saw you nodding there. Negative 44 meters. Is that the height of the building? No. Really, it should be, right. But if you believe it as negative because you just solved for the displacement, which is, by the way, the correct displacement, I'd mark that right. Okay, the height of the building isn't really the displacement, though. It's the magnitude of the displacement. You guys okay with that question? Yeah. All right, then, let's have a look at question number 2. This one says a ball was thrown with a velocity of 20 meters per second at 30 degrees. All right. Right away, we know we're going to get our funny angle here. It's going to go like this, right? What's the shape of that path called? Parabola. What's the shape of the last path when it was launched horizontally off the edge of the building? It was a parabola too. It's just a half a parabola instead of a whole one, right? 20 meters per second, 30 degrees. Travels for 3 seconds. Okay, we got the time again. We want to find out the distance that it travels horizontally. Question B says the height from which it was thrown. So it looks like I got a little mistake there. It looks like it was launched. It was thrown from a certain height right here. Make sense? We want to find out what this height is. And we want to find the maximum height of the ball. Interesting. We want to find this height right there. Okay, 3 things. First thing, hey, we got a funny angle. What do? Get rid of it, right? Let's get rid of the funny angle. Let's go off to the side over here. Sorry, those. Not a big fan of funny angles, eh? Good, I'm not either. This is x, this is y. We're going to say for the x component, cosine 30 degrees, because x is the adjacent side of the triangle, 20 is the hypotenuse. Adjacent and hypotenuse goes with cosine. Cos 30 is equal to adjacent over 20. And I think that works out to be 17.32. The y component, we're going to say sine 30 degrees is equal to opposite over hypotenuse. This one's easy. Y is equal to 10 meters per second. So then we do our thing, right? We go back to the x and y components here. For x, listen, we don't have a choice. Stephen, what do we got to use for x? Yeah, but what equation do we need to use? Good. V equals d over t. And you're right, its velocity is going to be 17.32 meters per second. The displacement here is, we don't know, we're trying to find that, right? And the time is 3 seconds. Oh, look at that. We can find the displacement again right away. We can't do that with all the questions we see, right? But in this one, the last one we could. Delta D is equal to 3 times 17.32, which gives me 52 meters. Almost exactly 52 meters. The y component, so A is done now. The y component, we're going to say D is equal to VIT plus 1/2 AT squared. Delta D is equal to VI is 10 times a time of 3. It's 1/2 negative 9.81 times 3 squared. Do the math there. Be careful. This is positive, but this term is negative. So it's 30 minus something. End up doing the math there. Works out to be 14 meters. B is done. Sure, that should be negative 14 meters, right? But what did we say just a minute ago? When we solve for the displacement and it's a negative value because it's downward, then the height from which it was thrown is positive. Negative, positive, doesn't matter in that case. I can live with either one. The maximum height of the ball, though, this is the one that I really was really interested to see what you could do when I assigned this question. Katie, did you get that one, the maximum height? Anybody get the maximum height? Yeah? Good. What'd you do?
I found the funny angle, like triangle, and then I just did that figure out.
Oh, no, that's not gonna work.
I got 19 though.
Okay, you got lucky then.
I don't know how I did it.
If you use just a Pythagorean theorem and you end up getting the answer, it is conceivable that could happen, right? But no more conceivable than getting 18 or 16 or 21, right? So the idea is wrong there. How do we tackle this? There's a couple ways, but one way is definitely the easiest way. The way that I would suggest you solve that question, the maximum height, is to go to the y component, because height is a y variable, right? And analyze not the entire trip like I just did. Okay, I don't want to repeat what I just did with the y component right there. Why would I? I've already done that. Let's analyze the y component for part of the trip. Let's analyze the y component up to here, to maximum height, not from start all the way down to finish. You guys have learned that, what was the x component of that? 17.32 meters per second. The initial y velocity was 10 meters per second. You guys know that horizontally, the velocity doesn't change. Horizontally, if it's 17.32 here, then it's 17.32 here, and here, and here, and here, and here, and here. It's 17.32 horizontally the whole time, because there's no forces to slow it down or speed it up. Vertically, though, you guys know that it will slow down as it goes up, reaches a peak height, and then speeds up as it comes back down, right? Vertically, how fast is it moving right here at its peak height? That's really what I care about, right, is the max height, the peak height. How fast is it moving vertically at that height? Not horizontally, because horizontally I know it's still 17.3. But vertically it's moving 0. It's at rest. So what we're going to say is we're going to analyze this trip to its max height. In other words, we're going to say VF squared is equal to VI squared plus 2A times delta D. VF is going to be the speed right here. It's going to be 0. VI is going to be the initial speed. Do the math here. What do we get? 0 is equal to 100. Subtract 19.62 times delta D. Negative 100 equals negative 19.62 delta D. What do we get for delta D? It's about 5. 5.1 maybe? .096, 5.0968 meters. All right, guess what? It's not my final answer. I'm not done. Look at the answer over here. It said it was 19. Where did I get 5 from? Cody? Okay, good. So I launched it from here, and the displacement was 5 meters up, right? Good. So if I want to find its maximum height, I got to find the displacement that I just got, right, above its initial height, and then add to that how high it was above the ground to begin with. Make sense? You are more likely to see a question involving max height where it's launched from ground level, comes back down to ground level. Okay, if that's the case, then you're going to do the same thing for the y component. VF squared is equal to VI squared plus 2AD. Set VF equal to 0. VI would be whatever, let's say 10 again. But this time delta D would be your answer. There would be nothing to add it to in that case, right? That's what you're more likely to see. Got it? All right. Got a little bit of homework for the weekend, guys. You got 4 long days, and I know you're going to be bored out of your skull this weekend with the beautiful weather, wondering, what should I do for schoolwork? Okay. What could keep me away from the boredom of being outside doing something? Okay. What could I do inside to keep me entertained? Well, this is what you can do to keep you entertained. We'll go page 112, questions 1 to 9.